Hey, welcome to another class. Feel free, as I'm going through this, you can pause it wherever you need to in order to stop to try a problem on your own. I would recommend anytime that a new problem appears on the screen, I would try it yourself first and then watch the video going through. But I'm just going to be working straight through. So, first up on this warm up, we've got the point 0, 0. And then we've got the point 5, 7. We can connect our lines, and we've got A, B. So this first operation that we're doing here, this is a translation. It's what we did last class. Translation. So this means that we are taking the shape and we are physically just moving every single point. Now, when I'm doing this, I like to just take each point, go, okay, I got A. A needs to go back 6. 1, 2, 3, 4, 5, 6. Up 2. 1, 2. This is the point I'm looking for. I'm looking for this point right here. I'm back 6, up 2. And then I need to do the same thing with B. B needs to go back 6. 1, 2, 3, 4, 5, 6. Up 1, 2. I get this coordinate right here. A prime, B prime, line segment. And I can double check these points, make sure that they fit with my rule by looking at the point and applying the rule to the points. A prime, if I plug in 0, 0 minus 6 is negative 6, and 0 plus 2 is 2. Is this the point 6, 2, or negative 6, 2? Negative 6 up 2. Yes, it is. And do the same thing here. B prime, I've got 5 minus 6 is negative 1. 7 plus 2 is 9. And that is, in fact, the point that I have here. So I'm all set. It looks good. There's one more thing to do. We just need to write a sentence. And for a translation, it should look something like this. Line segment AB is translated negative 6 units in the X and 2 units in the Y. I would say that the labeling here on all of the points, having this, and having a good sentence right here explaining it in words, those are the really important parts. That is the stuff that's going to be differentiating the grade that you get beyond passing, is can you do this well? So today, your notes, you're looking at reflections. So reflections use a line like a mirror to flip the shape. Pretty straightforward. The way I like to think of it is if you were to come in here and be looking at this thing, if we have some mirror here, and in math, we're going to call this the axis of reflection. You might also see here the word line. That works as well. I like axis because it makes me feel a little smarter. I also just happen to know some of the terms that are coming at you here in the next year. Axis is a good word to be paying attention to. So if you're looking at this, and we'll call this up here, we'll say this is the mirror. If you're standing there and you're looking at yourself in the mirror, when you're looking at yourself and you see this mirrorverse you standing in there, when you look at it, you are the same distance away from the mirror as the mirror you is. It's not like you look in the mirror and magically, all of a sudden, your face is just zoomed in. Like you're standing back 3 feet and all of a sudden all you see is your nose in the mirror. That's not how most mirrors work. And like if you have something behind you, like a picture, Get a nice landscape here. That we've got this nice little landscape that if we're looking in the mirror, it's really hard to draw backwards. Sorry, needs to be a snow-capped mountain. My bad. Now when we're looking at it, the mirror, you got the same distance from picture to picture. Everything is exactly the same distance away. So when we're thinking about this, we're going to take this idea forward with us as we're looking at reflections. So let's take a look at this example here. So this one, they already give you the points are all labeled. You're given all of the pictures. We're just kind of coming in and doing the analysis on top of it. So are these two triangles, or I guess they say shapes, it's kind of generic. Are these two triangles congruent? Well, looking at it, I would say yes, because B prime to C prime, I can't measure that exact length, but I can look at this and say, well, this is a 2 by 4. And B to C is a 2 by 4. AC is a 2 by 8. A prime C prime is a 2 by 8. A to B is a 4 by 4. A prime B prime is a 4 by 4. We're not quite to this point where we really need to be doing this, but I want you to see it. I want you to start thinking about it. That yes, these two things are congruent. So then I can come in here and I can say this. Kind of the starting way you can think about this is, yes, they are congruent. But eventually we want to write this like a mathematician. And a mathematician would write that triangle ABC is congruent. We just have a little equals sign here with a squiggle on top. Is congruent to triangle A prime, B prime, C prime. So this is kind of the I don't know what I'm doing. This is the, hey, look at me. I'm a mathematician. Which a big chunk of that is trying to look smarter than you are. So it's a good thing. Act like it. If you act like what you want to be, you are more likely to become it. My dad would always tell me, playing baseball, when I was going out to practice, dress like a baseball player and you're going to play like one. That if you show up to practice in basketball shorts and a tank top, you're not going to play like a baseball player. Put on your socks, put on pants, put on a long sleeve shirt, and go out there and play. Same thing here. Act like a mathematician. Write it the way we would. Next up, we want to describe this transformation of words. Well, I like to do the rule first because for me, the rule kind of tells me what I'm doing. It kind of informs my decision here. So looking at this, I need to take A, that is the point 4, 9, and I need to make this A prime, that is negative 4, 9. And I would encourage you, pause the video, go and look at this and think, how would I do this? So hopefully you've thought about it. Hopefully you've come to a conclusion of what your rule is going to look like, what this XY becomes. While I'm looking at this, well, my Y value doesn't change. So I'm just going to leave it alone. So XY is kind of just place filler things. It's variables to represent any value. The Y is going to stay the same. But looking at this, my X value goes from positive to negative over here. So how do I do that? Well, I do that by taking n, multiplying by negative 1. And if I take this rule, I'm not sold on it yet. This is just a hypothesis or just a guess. I need to test it against everything. So clearly I think it works here for A because that's what made me think of it. B 8, 5. Well, I'm not even going to look up here. Let's get rid of that. Scribble that out. I didn't even look at it. I'm going to test my hypothesis. So according to my hypothesis, B prime should be -8, 5. If I reveal, aha, it worked. Now let's try that one last time on C. C is the point 6, 1. C prime, according to me, is -6, 1, which works. So now I'm confident to say that this is no longer a hypothesis. This is my answer. It's box-worthy, as I will call it. So now I need to somehow describe, well, what am I doing here? So one of the things that you can do if you're trying to find the axis of reflection is, and this is true of everything, if we go back to our little picture here, the axis of reflection is the line that is what we call perpendicular to the line that connects the two objects. So when we look at this, there's this line here that connects the sun in one painting to the sun in the other. There's a line that connects the eyes of you and your reflection. The line that is perpendicular to those is the line that goes straight, that creates this nice T-shaped 90-degree angle with those lines. So when we're looking at this, we want to connect all of the corresponding parts, all the things that are related to each other and are similar. So if I come in here and I'm going to use hot pink to make it really obvious, I'm going to connect A and A prime. I'm going to connect B and B prime. I'm going to connect C prime and C. And when I'm looking at these, I kind of draw those lines. I want to take and I want to split this line directly in the middle, perpendicular. And looking at this, well, yeah, this creates a bunch of 90-degree angles. So it's good there. Does it split the lines? Well, let's see. 1, 2, 3, 4. 1, 2, 3, 4. Seems good. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. It works. So think about it. Do we happen to know what this line is called? We should. This is the y-axis. So that means in this case, our axis of reflection is the y-axis. So if I'm writing this out, I'm going to write, and we're going to write it like a mathematician, that triangle ABC is reflected over the y-axis. So we get this shape here. We're reflecting it. I'm going to go ahead. I'm going to leave this one to you. Give this one a shot. But the one I want to talk about with you is this one here. So are they congruent? Yes, they are both 8 units long. So I will say that FG is congruent to F prime G prime line segment. And I can go in, I can find those new coordinate points. 1, 2, 3, 4, 5, 6. So both of these have an x value of 6. G is positive 3. F is negative 5. So now I need to think, how do I go from F is negative 5, 6 to F prime is 6, negative 5? Go ahead, pause the video and think about this for a second. And hopefully you come to the conclusion pretty quickly that, well, I just seem to have taken these and switched them. That these are just flipped. So it seems to me that my rule is going to be x, y becomes y, x. I'm just flipping the values. Now let's see, G is 3, 6. So according to my rule, G prime is 6, 3. And, well, yes, it is. So I feel confident enough to say that this is my rule. Now, how am I going to describe this? Well, I got to take a look at what is happening here. I don't know why my pen has decided to revolt against me. So when I draw my lines in here, connecting the image to the pre-image, I want to look at, okay, how do I split the distance between these things? So here I've got a diagonal distance of 3. So that means I need 1.5 diagonals. So right here, make that a little bigger, right there. And looking at this thing, I've got a diagonal distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I need 5.5. So 1, 2, 3, 4, 5.5. So now if I come in here and I connect those dots, I don't know how this thing got that was the line I was trying to do, so let me move it. That's just not going to do what I want. I guess we're just going to get a kind of wobbly line to get this thing looking decent. So we draw in our line. Now we have to think about, okay, do I know what the equation of this line looks like? And hopefully you do. If you don't, you should probably work on some algebra skills. But a line, we know, looks like y equals mx plus b, where m is our slope, or the change in y over the change in x, and b is the y-intercept. Well, very clearly, the y-intercept here is 0, 0. So that means that here on this equation, there is no b. And then the slope, well, pick a point. I'll pick 0, 0. And let's find another point on this line. So how about this? That looks like a point. There's 2 things crossing. So I go up 3, over 3, which means that my slope for this thing is 3 divided by 3, or 1. So I can just quite simply write here that this equation is y equals x. So I can just come in here and I can say, well, I took line segment FG. Line segment FG is reflected over the line y equals x. And that's it. That in my opinion, this is kind of like, this is the hardest reflection we'll do, the hardest. In my opinion, I would always swap this word here for the funnest. Make life challenging. And it'll make it way more interesting. A challenge for you, if you're interested, is I would recommend to think about, well, if this is the rule for reflection over the line y equals x, well, what about, kind of bonus question here, do it in purple, what's the rule for y equals negative x? So this is kind of like, this is the next step. If you're like, this is really fun, I love this, I want to take this even further, you might play around with, what if I reflect over any line? Because you can actually do that. There's some really cool stuff. Like, what if I just want to randomly throw in a line like this, and I want to reflect this thing over this line? Well, now we start to get some interesting things happening here. But that is not required. You don't need to do that. That's just me being a math teacher. So if you have any questions, please come on in, ask them. We cannot help you unless you come in and talk to us. Make sure you get the assignments done. You've got a test coming up here on Friday, in yeah, some point. So make sure you get that done. Have a good day.